Okay, now we're going to look at part C of this set of examples that's giving us sequences and asking us to decide whether or not they converge, and if so, to what value. Okay, and you can see from the sequence that we're looking at in part C here, this is quite a bit more complicated in terms of its formula than the previous ones that we've looked at. We've got a lot of square roots and other stuff going on here. So I'd like to take a minute just to rewrite that. Okay, notice that if we rewrite the top, the square root of n is really n to the 1/2. Okay, and so we can take 2n and multiply it by n to the 1/2 by adding those exponents. So n is really n to the first, and n to the 1/2 is, well, n to the 1/2. And if we put the n to the first and the n to the 1/2 together, by adding the exponents, we get n to the 3/2. Okay, if we do the same sort of thing in the bottom, that 3n square root of n turns into a 3n to the 3/2. Okay, and the square root of n is just n to the 1/2. Okay, and so we get a way of writing our sequence involving just powers of n. Okay, now to do this problem, we have the same choices that we did before. We could try to use L'Hopital's rule on this, but there's a catch. Taking derivatives of this fraction is not pleasant because our powers are fractions. They're not whole numbers. Okay, so if we tried L'Hopital's rule, what we would probably discover is that we wind up in kind of an infinite loop. The derivatives just keep getting worse and worse, and we don't get anywhere on the problem. So here's a situation where the alternate solution that we did in the previous example is going to be more useful to us than L'Hopital's rule. All right, so we'll start by taking the limit of this. Okay, so I'm just going to recopy the function that we've got. Okay, let me correct an error right there. That should have been a 2. 2n to the 3/2 over 3n to the 3/2 plus n to the 1/2 minus 2. Okay, and the way, again, that the dominant power method works is that we look at the denominator and we find the thing that's growing the most rapidly as n gets big. In this case, it's the n to the 3/2. Okay, and we're going to multiply the top and the bottom of our fraction by 1 over that. All right, as before, in the previous example, that has the effect of taking every single term and just dividing it by n to the 3/2. So our new numerator, the 2n to the 3/2 that was there, is going to get divided by n to the 3/2. Okay, and in the denominator, all of those terms are going to also get divided by n to the 3/2. Okay, pardon me, I got that exponent wrong. Okay, and then minus 2 over n to the 3/2. Okay, you might look at this and say, God, this is not looking good. This looks a lot more complicated than what we started with, but again, we're hoping that some nice things are going to happen when we cancel. All right, for example, notice that there are some n to the 3/2 that cancel out for us. Okay, once in the numerator and once in the denominator. Okay, and then if we look carefully at this fraction that I'm circling here, we've got an n to the 1/2 in the top and an n to the 3/2 in the bottom. If you cancel the n to the 1/2 that's in the top into the term that's on the bottom, notice that you're just going to get an n to the first power in the bottom by subtracting those exponents. Okay, so what ends up happening after we do all that simplification is the following. Okay, up here in the numerator, we've just got 2 left over because the n to the 3/2 canceled, and down below, that's just going to be a 3 for the first term. We just mentioned a minute ago that that red circled term is just going to turn into a 1 over n. Okay, and the 2 over n to the 3/2, nothing that we can cancel there. Okay, and now it's up to us to kind of look at this and figure out what's going on here. All right, so notice something interesting happens with the fractions that are left over, which I'm going to circle. 1 over n and 2 over n to the 3 halves. Both of those fractions are going to go to 0 as n goes to infinity. Which might illustrate the point for dividing by the dominant power in the first place. Okay, so what that means then is that when we take this limit, all that's really left is the 2 and the 3 in the top and the bottom, nothing else. And therefore, we can see what the value of our limit is. We wind up with 2/3, and so we have just shown that this sequence converges to that number.